Trig-free college, reciprocal identities. The previous video was trig identities, and that was all stuff from the trig reference sheet. That's not what this is. This is reciprocal identities. Like, let's look at this first question. What is tangent theta times cosecant theta? The key to all this is remembering that cosecants can be represented as 1 over sine because it's the reciprocal of sine. Secants, secant can be represented as 1 over cos. Cotangent can be represented as, well, actually, before I do cotangent, let me tell you about tangent, because we often, pretty much what we do for these is we try to express everything as sine and cosine. Even tangent, we want to turn tangent into sine and cosine, and so maybe you remember that tangent is sine over cosine. And so when I see tangent, I'm going to turn it into sine over cosine. When I see cosecant, I'm going to make it 1 over sine. When I see secant, I'm going to make it 1 over cos. Cotangent, instead of 1 over tangent, I want to think of it as the reciprocal of tangent, cos over sine. And when I have sine, I'm going to make sine just sine over 1. And when I have cosine, I'm going to just make it cosine over 1. But when I have these other functions, secant, cosecant, tangent, cotangent, I'm going to express them as sine, cosine, and tangent. So cosecant's 1 over sine, secant's 1 over cos, tangent sine over cos, cotangent's cos over sine. Okay, so tangent theta times cosecant theta. Well, tangent is sine over cosine theta, and cosecant theta is 1 over sine theta. And then what I'm going to recognize is I can simplify by crossing out sine thetas, and I end up with 1 over cosine theta, which is my final function, but I'm going to express it as secant, because 1 over cos is secant. That's basically what a lot of this is. It's just turning them into stuff like that, simplifying, and then what's left, what's that equal? This one is 3 of them. Cosecant, that's 1 over sine theta, times tangent is sine theta over cos theta, times cosine theta, which is already cosine, but I'm just going to put it over 1 because everything else is a fraction. I can cross these out. I can cross these out. So what's left? 1 over 1. Okay, I could distribute here. And I can distribute now or simplify them, and then I think distributing now is probably maybe a little easier. So this is going to become sine theta times cotangent theta minus sine theta cosecant theta. So sine, I'm going to keep sine, just put it as sine theta over 1. Cotangent is cosine theta over sine theta, reciprocal of tangent. Sine theta, I'm keeping sine theta over 1. And cosecant is 1 over sine theta. And so what I end up with here is these can cross out, and I have cosine theta minus, these cross out, 1. D. Tangent theta over secant theta. Well, tangent I'm going to express as sine theta over cosine theta. And secant theta is 1 over cosine theta. And fraction over fraction becomes times the reciprocal, so times cosine theta over 1. Right, I could flip the bottom, bring it to the top as multiplication, and now simplify this, cross out my cosines. I'm left with sine theta over 1, which is just sine theta. All right, the next one and the last one I want to do is a little bit different, because let me go back here. These four reciprocal identities are what we've used in the previous problem. Secant's 1 over sine, cosecant's 1 over sine, secant's 1 over cos, tangent sine over cos, cotangent cos over sine. These are reciprocal identities, and that's really the focus on here, but we're also going to add to this video Pythagorean identities. And Pythagorean identities is what we're going to be using for this. And this is something that you're going to have to memorize And when it comes time, we're going to add it to our reference sheet when we get to our test prep. That there's an identity that is sine squared theta plus cosine squared theta equals 1. So anytime you have sine squared plus cosine squared, it equals 1. And this is a really important identity that comes up on pretty much every Regents exam. That's why we'll be adding it to our reference sheet. You know, when we get into test prep, we're going to practice adding formulas to our reference sheet that are not there. Like we're going to add the quadratic formula. We're going to add the sum and product formulas for quadratics. We're going to add this identity to our reference sheet. But not just this. There's different variations of this. That I could solve this equation for sine theta. Like if I wanted sine theta alone, I would minus cosine squared to the other side, and I'd be left with sine squared theta equals 1 minus cosine squared theta. So you see that it's the same thing. I just subtracted cosine squared to the other side. And then the third variation is, well, what if I want cosine squared alone? I would subtract sine squared. So that would leave me with cosine squared theta equals 1 minus sine squared theta. And so these are really the variations of just this main identity. And then you could get even more complicated where I could divide everything by sine squared, and this would become 1 cotangent squared and cosecant squared. Or I could divide everything by cosine, and I'd get tangent plus 1 equals secant. You know, I'm not going to list those now. We will probably talk about them in class, but just know that there are other variations of this. But this is really the key one to know, and then these, simple just subtraction ones that come from it. So a problem like this, what I see on top, sine squared plus cosine squared, that's just 1. And 1 minus sine squared is cosine squared. And 1 over cosine is secant. Well, 1 over cosine squared is secant squared. And so that's it. They're actually easy problems. If you know these, you just need to know them. So definitely take some time to just really think about that and get that into your memory, and maybe write it a couple of times to practice that. But that's one of those things that you just have to have memorized to really be successful in this. So the basic ones are just doing these simple reciprocal identities with these and crossing out what's left over. That's not bad. But when you start to see things that get a little bit more complex like this, that's where they're called Pythagorean identities, and that's where these will come in. Okay, that's it.